Okay, so this video is going to cover how to solve a system by the elimination method. I will use this example here, which is going to be my simpler example. And then right after this one, we will cover one that involves just a little bit more. So starting with this example here, we're solving the system by the elimination method. And one of the first things that we do need to be aware of when it comes to solving a system by the elimination method is that it's in the proper form. In order to solve a system using the elimination method, our equations must be in standard form, which essentially just means our x term comes first, followed by our y term, and that is set equal to our constant. So taking a look at our equations that we have here, we do have them already set up in the proper form, which is good, which means we can move on to our next step. So essentially, our goal for solving a system using the elimination method is that we want to be able to add our system together in the hopes that one of our variables, either the x's or the y's, are going to cancel out. So we're literally going to stack this on top of each other and add it just straight up and down, just like we have here. So we would do x plus x to give us 2x. Y minus y actually cancels out, which is what we are looking for. And that's going to equal 1 plus 15, which is 16. Now this is going to give us an equation that we can solve because here I have 2x equals 16. I can solve for x by dividing out the coefficient. So 2 will cancel on the left-hand side. X equals 8 since 16 divided by 2 is 8. Now what we can do with this 8. So remember, when it comes to solving systems, we have one of three situations that we're trying to figure out. We either have the situation where we have our two lines crossing here and they meet at a single intersection point. We can also have the situation where we have two parallel lines, which means they never cross, never intersect, so we would actually have no solution. Or we can actually have the third situation where the two lines actually end up being the same line, and that means that those lines are right on top of each other, and every single point on that line would be a solution, therefore giving us infinitely many solutions. So these are the three cases that we could have when it comes to solving systems. Now, for the most part, when we're working elimination method, especially getting an answer like x equals 8, that's more than likely going to mean that we're going to have the first situation where they are crossing at a point. I'll do a video later where we have the two special cases, and I'll show you what those look like then. But if we have this first situation, which we're going to assume that we do, that means that our solution is the point where they intersect, which means I need to figure out what that point is. Now, here so far in this process, by adding these equations together, we got y to cancel out, and we got that x equals 8. Well, that means that 8 is my x value for the solution point. All we need to do is figure out what y is, which means all we have to do is come back up here and grab one of those equations. It does not matter which one. I'm going to grab the top one just because, no particular reason. If I wanted to grab the bottom one, that would be fine too. And since I know that x equals 8, I'm going to plug in 8 and I'm going to solve for y. Solving for y, all we have to do is subtract 8 on either side. So on the left-hand side, 8 minus 8 cancels, and I get y is equal to -7. So I'm going to plug in that -7 for our y value here, which is going to complete my point. What this is telling me is that these two lines, if I were to graph them and get a visual, these two lines intersect at the point 8, -7. Therefore, that is the solution to our system. So this problem is solving the system using the elimination method, where we might have a little bit of tweaking to do to our equation. So what we know about the elimination method is that we want to be able to add our system in the hopes that something is going to cancel, that one of our variables is going to cancel. So let's just test this. let's go with just straight adding our system and seeing what we get here. So if we're going to add it up, we have 1x plus 6x to give us 7x. Negative 3y plus negative 4y is a negative 7y. And negative 11 plus negative 24 is negative 35. Well, nothing cancels out here, which does not help me here. So what I'm going to do is I'm going to backtrack. So I'm going to clear this. Okay, so what we have to do if nothing automatically cancels is think about, okay, well, why did something cancel? And let's take a look at that last example that we just covered. We had x plus y equals 1, and then we had x minus y equals 15. And we saw that the y's were able to cancel for this one. And the reason why they were able to cancel is this. First off, they had the same number as their coefficient. They each had a 1 in front. The only difference is that one was a positive 1 and one was a negative 1. So that means in order for them to cancel, I have to have the same coefficient but different sign. They must be opposites of each other. So if our equation is not already set up to where one of the variables is opposites, we need to make it so. And we can force the equation to look the way that we want. Just like when we convert fractions in order to add and subtract fractions, we can actually convert our equations to look the proper way. Now, I'm going to work on canceling out the x's. No particular reason, just because the x is in front, and that's a little bit easier to work with. So what I can do, if it's not in the proper form, I can multiply the equation by something to put it in the proper form. So if I'm looking at my x values, okay, what I want to do is I want to come up with the first number that they have in common. By what I mean by that is take a look at the coefficients. The coefficient of x in the top equation is 1. The coefficient in the bottom equation is 6. I want those numbers to be the same. So if I want them to be the same, the first thing a 1 and a 6 has in common would be a 6. So if I wanted to make that top equation be a 6x, well, I have a 1 in front. 1 times a 6 would give me a 6. So if I multiplied that 1 by a 6, it would give me a 6, which is what I need. But I can't just multiply that 1x by the 6. If I change that x, I have to change everything in the equation. So what I've done is I've drawn these parentheses around the equation because I'm going to have to multiply everything in the equation by that 6. Kind of following that principle, what we do to one side, we must do to the other side of the equation. Well, if I'm going to multiply that x by 6, I have to multiply everything by 6. And that is going to give me the 6x to match up with the 6x here. The only thing I need to worry about is that I need one of those 6's to be negative, right? Because they have to have different signs in order to cancel out. So since I'm already multiplying the top equation by a 6, what I'm going to do is make that a negative 6, because that's going to give me the different sign. So let's go ahead and carry out that distribution. We're taking negative 6 times x, which is a negative 6x. And then a negative 6 times negative 3y, that gives us a positive 18y, is equal to negative 6 times negative 11, which is a positive 66. That bottom equation we did not tweak, so I'm just going to go ahead and drop it down so that we can add our system together. And hopefully this time around something will cancel. So adding our equations together, well, negative 6 plus 6 cancels, which is what we were hoping for, yay. Adding our y terms, we have 18y plus negative 4, which is a 14y, is equal to 66 minus that 24, which gives us a 42. All right, so all we have to do to have this equation solved is to divide out the coefficient. So divide both sides by 14, and we get that y is equal to 3. Now that we know what the y value is, remember we are solving for our intersection point, which means we need a y as well as an x value. So here we got that y is 3, so I'm going to plug in a 3 for my y. And we need to solve for x, which means I can go right back up here and grab either one of those equations. I'm going to take the top one, x minus 3y is equal to negative 11. And we're plugging in 3 for y. And we're going to simplify this so we can figure out what our x value will be. So when I do negative 3 times 3, I get a negative 9. And the last step would be to add 9 to both sides, and we get that x is equal to a negative 2. So I'm going to plug in a negative 2 right over here. I'm sorry, I just realized that you probably can't see that, where x is equal to a negative 2 after we do minus 11 plus 9. So we get the point negative 2, 3 as our intersection point.